In this problem, we want to do a better job hiring people. We already have 300 people that are doing a certain job, and we've been hiring them by interview. And that's given us a whole range of, of people, some of whom perform very well, some who perform less well. What we want to do is we want to test out a couple pre-made tests that purport to measure the skills that are necessary for this type of job. And so what we have here is we have some data from 10 different employees that we currently have. So we give them the first two, we give them each two tests, and then we also have their performance ratings from last year. So we know how good of employees they are, more or less. Now, what we need to do is we need to set up the data from what is given. And we're gonna put down the employee number, their work performance, and their two test scores. Now, the way that we set up data is we always set up each column is a variable. So let's put the for variable here. We'll call this employee for their employee number. I'm going to do test 1, test 2, and performance. That's the data that we have in the book there. And so it's going to go, we've got employee numbers 1 through 10. Okay, so let's highlight those two, and let's pull this down, get up to 10. Okay, there we go. Now we've got to enter in their data. We got to be careful not to mess it up. 10, 19, 20, 20, 21, 14, 10, 24, 16, 14. Okay, now we've got to give their test 2 scores. 25, 35, 40, 49, 50, 29, 32, 44, 46, 35. Now, hopefully that is correct. I'm checking over. Okay, and now we've got some performance scores. The first one got 50, 74, 62, 90, 98, 52, 68, 80, 88, and 76. Hopefully I've entered those correctly. Okay, now let's change this into a table. Go to Insert, Table. That looks good. Table with headers. Okay. All right. Now we want to find the follow the various questions that they ask there. So this construct a scatter plot of work performance and test 1, looking at using test 1 as the x variable. Okay, so we're going to use test 1 as our x and performance as y. We're going to make a scatter plot. Now remember, we need to make sure we get just the right column. So I'm not even going to try to make a scatter plot out of a table with 4 columns. I'm going to copy these 3, Control copy, put them over here, do Control V. Now, we don't want test 2, so I'm going to delete this column. So right-click, delete, and there we have just our 2 variables now. Now we can make a scatter plot. So I go to Insert, Scatter Plot, first one, and we've got a scatter plot. It looks kind of got a lot of blank space there. So let's see if we can change the layout. Let's go our add chart uh, element. Let's look for axes options, and the bounds go from 0 to 30. Let's change that from 10 to 25. 10, and then let's go down to 25. And that gives us a lot better there. Okay, so the 10 to 25. Let's close that. Let's change the y-axis also. Axes, the vertical axes. Great. Okay, now let's change the y-axis. So let's go into here and choose design, add chart element. Let's go to the axes, the primary vertical axis. Let's choose that and choose the options. Let's see, it's probably one of these buttons there. No, no. Let's go back here and add chart element, axes title, more axes options, and that gives us the same thing. Let's see if we can find it. Data, why can't we find text options? Oh, how about this is where we should be looking at vertical values axis. And so let's click there. I wonder why we can't get rid of, let's get rid of that thing and go, if we move that over there, okay, that gets there. Tick marks, axis options, bounds. Okay, there it is. So it's going from 0 to 120, and we want to go from 40 to 100. Let's change that to 40 and about 100 there, and that's good. And so now we've got a that looks like a pretty good scatter plot there. So let's change the axis titles. We'll put this is the x variable, so this is test 1. This is going to be performance over here. Performance. We got an extra A in there. Performance. And let's call this test 1 as a predictor of performance. Test 1 as a predictor of performance. And let's put a trend line in. So we can go to add chart element, trend line. Let's go for more trend line options. It'll choose linear for us automatically. And we're going to do display R squared. And there we have our, let's undo that. Let's drag the whole chart over there. And let's see what we've got there. Okay, we've got R squared equals 0.350. Now, B says, assuming that is linear, compute the value of the Pearson R. So let's go over here, and we'll use data analysis. We'll do correlation, and we'll do OK. Input range are going to be our two variables here. Grouped by columns, labels in first row, output range, click in the output range box, click where we want the output, and we press OK, and let's round this to 2 decimal points. And we've got R equals, so Control I, R, Control I, so we have R in italics, space equals 0.59. Okay, so that is A and B. So that first test is a pretty good predictor, a correlation of 0.59. We can see that there's a good amount of error in there, but in general, the scores go up as the people's performance goes up as the score goes up. So now let's take and do the same thing for C using the second test. So we're going to copy this one. We can just copy these 2 columns over here. Control copy, and we can put it down here. Control V. Let's change that into a table. Okay, now let's make a scatter plot out of it. So we're going to go to Insert, the scatter plot, and there we got a scatter plot right away from there. And let's adjust the axes again. So let's go to, make that selected, add chart element, axes, more axes options. Okay, so we've got going from 0 to 60, and we want it to go, say, from, let's see, what did we have? We had 10. Oh, this is a totally different test, isn't it? Look, the scores aren't even in the same range, which makes sense because they're probably made by different manufacturers. So we want the test scores to go from about 20 to 50. Or we just change 20 to 60. That's good. Leave it there. Okay. And change it to 20 to 55. That sounds pretty good. And so we've got those axes. Okay. Now, can we change to, actually, that's good enough. We can leave that there. Well, let's put in a trend line. Trend line. More trend line options. Linear. And then we want to display R squared. And there we go. So here we've got R squared equals 0.82. So this looks like, yeah, the dots are a little closer on this second test here. So let's calculate the correlation. Let's use our data analysis. Data analysis, correlation. Okay. Input range is now going to be M and N starting here, and going down there. Columns, labels in first row, output options. Okay, we want to delete that one. And let's put the output about here. Okay, and let's round that off. Whoops. Home, general, number, got to 0.91, so we can say that R, so Control I for italics, R, Control I for off, space, equals 0.91. So the correlation is much better for the second one, 0.91. So it looks like a test. Oh, we didn't label let's go back and label this. So this is test 2 as a predictor of performance. And let's make our conclusion that test 2 is superior to test 1. Test 2 is superior to test 1 for predicting performance. All right, and so this is how we can compare 2 tests using the correlation constant to see which one better predicts the performance.